My talk is on the cascading disasters and risk. And I'm going to illustrate this for two Philippine cases. The outline of my talk is here. You can just read through it in the interest of time. So complex systems are composed of a large number of components operating and interacting in nonlinear fashion. So this can be physical, biological, mechanical, or even a social system. So this illustrates that for electrical power, it can be cooled by water, and then you produce energy to support your transportation and then telecom system. You can even have water for cooling your telecom system and so on. So due to this interaction among the different components of a complex system, if there is failure, it's not due to a single factor, but compound effect of multiple factors. So a cascading failure, as illustrated here in a computer network, typically you would have nonlinear stochastic dynamic interdependent system. So this shows you animation of how a single computer starts failing that then will affect other components in a manner that you would then, you can have some computer repairs here and there, rebalancing, but then eventually your computer network can fail entirely. So if you were to do some risk analysis, you can have what we call cascading or compound failure modes, depending on the configuration of the system. And in our case here, we're interested in a compound failure mode, because you can have a serial system, and then in each component, in the serial component, you can have a parallel or redundant system for that matter. You have some simple formulas here to calculate risk, but in our case, it could be more complicated because you have a stochastic dynamic interactive components. In the case of Typhoon Haiyan, which was a super typhoon on October 8, 2013, generated 240 km/h winds that then resulted in storm surges, created tsunami waves 4 to 5 meters high. Then it cascaded this into a flood disaster, some failure in the airport, closed for a few days, and then also failure in electric power that for several weeks. And again, it cascaded into relief goods were delayed, communications were disrupted, no water because no electricity, and in longer term, response recovery took over 3 months, 3 years for that matter, sorry, from emergency to recovery and rehabilitation phases. In the case of the Mindoro earthquake, you have a magnitude 7.1 earthquake that was lifted a western portion of this province of Mindoro, where immediately it created a triggered tsunami, killing again several people, resulting in ground failures like liquefaction and landslides, and then flooding in this Nauhan Lake because of ground shaking and tilting of the lake. But over a period of 10 years, this mag-asawang tubig was captured by Bukayo River, so that in a series of typhoons in December 2005, the Bukayo River swelled, created massive flooding in the Nauhan area, in the Calapan area, which isolated Nauhan from the port of Calapan that essentially cut food supply for several months. So initially people blamed forest denudation, but it was actually due to the slow creeping capture of mag-asawang tubig by the Bukayo River. So as far as mitigating of this cascading disaster risk, we advocate evolutionary resilience, where in the case of both Typhoon Haiyan and Mindoro Earthquake, they were both complex systems, and the only way to really build resilience is through evolutionary resilience, or what we also refer to as socio-ecological resilience, or complex adaptive systems. So you adapt, learn, transform, not to the normal, but to the new normal for that matter. Thank you very much.